Certification of Service Technician Program, CSTP, Department of Environment, Malaysia. Standard Operating Procedure for Handling and Servicing Hydrochlorofluorocarbon, HCFC, Refrigeration and Air Conditioning Systems. To ensure the servicing work in an orderly and structured manner, these are the 12 checklists and guidelines the technician has to follow. Checklist 1. Personal Protective Equipment or PPE. Safety measures need to be emphasized to protect the officer from an unexpected incident of high concentration refrigerants. Personal protective equipment or PPE must be worn at all times to avoid the risk of skin problem, eye irritation, dizziness, drowsiness, headache, suffocation, and frostbite. The personal protective equipment includes safety helmet, goggle, respirator, glove, long sleeve jacket, safety boot, and safety vest. Checklist 2. Tools Inspection Procedures. Before commencing any servicing procedure, the technician must first perform tools inspection of the following items. Manifold gauge. Use suitable manifold gauge with the HCFC refrigerant. Check needle and calibrate if necessary. Technician may use either analog or digital manifold gauge. Ensure the manifold glass or screen is not broken. Check the condition of hose rating, hose seal, and valve nipple. Ensure it functions as required. Leak detector. The technician must check the leak detector condition to ensure no crack or broken. The detector must function well and able to detect the refrigerant leak during the leak test procedure. Recovery machine. To get an optimum performance of recovery machine, every technician requires to follow these steps. The technician must check recovery machine manifold, valve, and recovery unit condition to ensure no crack or broken. The recovery machine must function well and able to perform recovery process. The recovery machine's needle needs to be calibrated when necessary. Vacuum pump. The technician must check vacuum pump condition to ensure no crack or broken. To get an ultimate deep vacuum performance, the oil must be at a level referring to the manufacturing specification. The moisture from the air conditioning system tends to combine with the vacuum pump oil. As a result, it degrades the pump's ability. Hence, the vacuum pump oil should be replaced frequently following the manufacturer's specifications and procedures. The pump must function well and able to vacuum the system and meet the requirements specifications. Micron gauge. The technician must check the micron gauge condition to ensure no crack or broken. All cable, seal and nipple are in good condition. The micron gauge must function well and able to measure the vacuum status to meet the requirements specifications. Refrigerant charging scale. The technician must check the refrigerant charging scale condition to ensure no crack or broken. A well-calibrated scale should demonstrate 0 reading when in no load condition. An accurate reading is crucial to avoid exceeding the 80% tank capacity during recovery process, as it may explode in warm environment. The scale must function well and able to measure the weight of refrigerant as required. Clamp-on ammeter. The technician must check the clamp-on ammeter condition to ensure no crack or broken. Assure the clamp-on ammeter is working well and able to measure the system's running current and starting current. Recovery tank. The technician must check the recovery tank condition to ensure no rust and crack. All valves should be in good condition. Check the recovery tank labeling and assure The refrigerant type is the same with the system to be recovered to avoid mixed contamination. If the recovery tank is empty, which is indicated by 0 psig, the vacuum process needs to be performed. If the recovery tank filled with refrigerant, check the tank temperature and pressure chart to ensure the tank is not contaminated with air or non-condensable gas. Purge recovery tank if it's contaminated with air. Measure the recovery tank weight and calculation to avoid exceeding the 80% tank capacity during recovery process. Thermometer. The technician must check the thermometer condition to ensure no crack or broken. Assure the thermometer is working well and able to measure the temperature reading. Safety valve. The technician must check the safety valve condition to ensure no crack or broken. All valves should be in good condition. Checklist 3. Test run and inspection procedures. For good servicing practices, the following standard operating procedures for servicing the air conditioning of HCFC should be followed. The tools needed for the test run and inspection are Type K thermocouple, 4-way manifold gauge, clamp-on ammeter, and safety valve. In test run and inspection process, the technician requires to follow these steps. Switch on the air conditioner and wait for 15 to 30 minutes or refer to manufacturing specifications. Assure that the technician does not block the airflow before measuring the return and supply air temperature. Measure the return air temperature by placing the Type K thermocouple at the return indoor unit. Measure the supply air temperature by placing the Type K thermocouple at the supply indoor unit. The return air temperature and supply air temperature differences must be within 8 to 12 degrees centigrade. If the temperature differences are within 8 to 12 degrees centigrade, the technician can proceed to servicing procedures. However, if the temperature differences is not within 8 to 12 degrees centigrade, the technician needs to inform the owner and suggest further troubleshooting procedures. Low pressure. Securely connect the 4-way manifold gauge to the safety valve and safety valve to the condenser unit in fully closed position. Open the safety valve and record the pressure reading. Make sure the pressure reading achieves manufacturer's specifications. Running ampere. Measure the compressor current by placing the clamp-on ammeter around the live cable at the condenser unit. Refer to manufacturer's specifications for standard current value. Checklist 4. Recovery procedures. The technician is advised to assure the air conditioner is in power-off condition before performing recovery procedures. The tools needed for recovery procedures are 4-way manifold gauge, micron gauge, vacuum pump, filter dryer, recovery machine, recovery tank, refrigerant charging scale, and safety valve. Before the commencement of recovery process, the technician needs to perform the connection procedure as shown in the diagram. There are two possible methods for this procedure. The first method is only applicable with refrigeration and air conditioning system without service valve connection. Piercing plier will be used in this service method. To perform this procedure, fix the piercing plier tightly into the refrigerator system to ensure no refrigerant leakage. Used piercing plier to make a hole on the copper tube. The pressure will be indicated by the movement of the pressure gauge needle. The second method is the connection procedure with the service valve. Check the connection of manifold gauge to the air conditioner suction service valve and secure it with a safety valve. Secure the manifold gauge vacuum hose to vacuum pump through micron gauge. Assure the connection is properly connected. Ensure the filter dryer's arrow direction when connecting the filter dryer to the recovery machine and service hose manifold gauge. To avoid contamination, different refrigerant must use different filter dryer. Connect hose recovery tank vapor valve to the recovery machine outlet. Place recovery tank on refrigerant charging scale to avoid overfilling the cylinder. Connect recovery machine safety cable if applicable. Before commencing the recovery procedure, ensure all connections are correct and tight. Switch on the vacuum pump. Switch on micron gauge. Open manifold gauge VAC valve. Open manifold gauge REF valve. Make sure the vacuum pump's reading reaches to minimum 1000 microns and make sure the valve at recovery tank is in closed position. This procedure is to minimize cross-contamination hose and to remove moisture. After reaching 1000 microns, close all valve manifold gauge, VAC and REF and then switch off the micron gauge, vacuum pump and its valve. Turn the recovery machine knob to recover function. Open the vapor valve of the recovery cylinder. Open low valve at manifold gauge. Open REF valve at manifold gauge. Turn inlet valve at recovery machine to liquid position until pressure reading appears. Open recovery machine outlet valve. Check possible refrigerant leak using a leak detector. Before starting the procedure, technician is advised to take measurement and record the recovery tank weight for future reference. Connect recovery machine to power supply and assure the power supply is on. Switch on power button at recovery machine. Switch on auto off mode. Switch start button. If no knock or vibration sounds, fully turn the inlet valve from the liquid position to the open position. Wait until the recovery machine inlet pressure gauge reaches 0 psig. The recovery machine will automatically stop. Close all manifold gauge valves. Close inlet valve recovery machine. Pressure will rise as the refrigerant filled in the recovery machine. Turn the recovery machine knob to the purge function. Press start button on recovery machine. Wait until inlet pressure gauge recovery machine reaches 0 psig. Then, the recovery machine will automatically stop. Record the quantity of the recovered refrigerant. Close recovery machine outlet valve. Close recovery tank vapor valve. Switch off the auto off mode and power and disconnect the recovery machine from power supply. Disconnect and open the outlet valve to release the pressure. Extra precaution is needed as a small amount of refrigerant is still present in the hose and high pressure gauge. All connections need to be capped. Checklist 5. Cleaning and flushing procedures. Cleaning and flushing are important steps to the HCFC air conditioner servicing practice. Standard operating procedures for cleaning and flushing are as follows. The components needed for the connection procedure are condenser, evaporator, and nitrogen cylinder. Condenser procedure. Connect the nitrogen cylinder to canister with a hose. Connect the canister to the condenser. Always use solvent and dry nitrogen during the procedure. A nitrogen cylinder must be fitted with a two-stage pressure regulator with the pressure requirement between 72 to 145 psig. The usage of hexane or methylene dichloride (MDC) is compulsory during this step. Before completing this procedure, the technician is advised to check and ensure no trace of liquid hexane or methylene dichloride (MDC) after the cleaning is done. Evaporator procedure. Connect the nitrogen cylinder to canister with a hose. Connect the canister to the evaporator. Always use solvent and dry nitrogen during the procedure. A nitrogen cylinder must be fitted with a two-stage pressure regulator with the pressure requirement between 72 to 145 psig. The usage of hexane or methylene dichloride (MDC) is compulsory during this step. Before completing this procedure, the technician is advised to check and ensure no trace of liquid hexane or methylene dichloride (MDC) after the cleaning is done. Filter dryer replacement procedures. To ensure the optimum performance of the HCFC system, the technician is required to carry out the necessary filter dryer replacement according to the manufacturer's specifications. Checklist 7. Choking and pressure test procedures. After the repair process, it is necessary to pressure test the system to ensure that there is no choking or blocking due to improper bracing, particularly at the end of the capillary tube. Connection procedure. The technician is required to perform a connection procedure as follows. Connect the service hose manifold gauge to the nitrogen cylinder. Connect the high-pressure manifold gauge to the suction service valve air conditioning system. Pressure procedure. Use dry nitrogen to pressurize the systems at 2 bars at least for 10 minutes. If there is no leak or choke detected, increase the pressure to 10 bars for at least 10 minutes. Ensure there is no choke at liquid line connection. Place a piece of paper on the outlet of both connections to check nitrogen flow. The movements of the paper indicate the presence of nitrogen flow. Checklist 8. Nitrogen leak test procedures. Refrigeration systems are designed to operate adequately with a fixed charge of refrigerant. If a system has insufficient refrigerant charge, the system must be checked for leaks, repaired, and recharged. It is important to perform nitrogen leak test after repair and service process. These are the necessary procedures every technician should follow for servicing HCFC's appliances. Technician is required to check and tighten the connections as follows. Manifold gauge high-pressure hose to suction service valve. Manifold gauge service hose to nitrogen. Pressurize the system to the manufacturer's specifications pressure with dry nitrogen and close the cylinder valve when the gauge reading reach 20 bars. To avoid unexpected incident, it is advisable to apply nitrogen pressure stage by stage until it reaches 20 bars. Stage 1. Supply 10 bars of nitrogen to the system and wait for 10 seconds. The pressure indicator should remain at 10 bars if no leakage is present. The technician may perform leak test procedure by applying a spray leak detector or a liquid neutral detergent on the RAC system connections to assure no leakage is present. Stage 2. Add additional 10 bars to the system and wait for 10 seconds. At this stage, the pressure indicator should reach 20 bars. The technician may perform leak test procedure by applying a spray leak detector or a liquid neutral detergent on the RAC system connections to assure no leakage is present. Finally, if no leakage is present during the test, the technician may release remaining nitrogen to the atmosphere slowly. However, if the leakage is present at any stage, the technician should execute with the repairing process. Checklist 9. Vacuum procedures. Evacuation is very important to remove non-condensable gases and moisture. HCFC systems need a deep vacuum of 500 microns or lower. This process requires a two-stage vacuum pump, which is capable of pulling vacuum between 20 to 50 microns, and a micron gauge, which is capable of reading from 5 to 5,000 microns. Technician is required to make a proper connection to the system as follows. Make sure all manifold gauge valves are in the closed position. Connect the low side hose manifold gauge to the suction service valve with safety valve. Connect micron gauge to manifold gauge and vacuum hose to vacuum pump. Connect the REF hose to the vapor valve on the refrigerant cylinder. Switch on the micron gauge. Switch on the vacuum pump and open the shutoff valve. Open the VAC valve at the manifold gauge. Open the low valve at the manifold gauge and open safety valve. Open the REF valve at the manifold gauge. Wait until the micron gauge reaches 500 microns. Close the shutoff valve at the vacuum pump and switch it off. Hold for 10 minutes or more and monitor the micron gauge reading. If the micron gauge reading increased to 1,500 microns, it indicates leakage in the system. If no leakage is present, close all manifold gauge valves and proceed to charging process. Checklist 10. Charging refrigerant procedures. Accurate refrigerant charging is very important to the air conditioning and refrigeration system. Manufacturers are always designing the system with a specific refrigerant charge. To avoid undercharging or overcharging, the technician must always refer to the manufacturing label to get the correct specifications before performing any procedures. The tools needed for charging refrigerant procedures are refrigerant charging scale, 4-way manifold gauge, and leak detector. Refrigerant gas in the recovery tank should be tested using refrigerant identifier to ensure purity of refrigerant before charging to the system. Technician is encouraged to use pure refrigerant that meet the RE Standard 700 specifications. Before the commencement of the procedures, the technician needs to make sure the air conditioning system is in off condition. Ensure all hoses already vacuumed to minimize cross-contamination. Identify and set the amount of charge to be used. The best way to charge the refrigerant is by weight. The technician must place the refrigerant tank on a refrigerant charging scale to perform the procedures. Measure the recovery tank weight. Open vapor valve on recovery tank. Set the manifold gauge low valve to open position. Close high and VAC valves. Open manifold gauge service valve labeled with REF and monitor the refrigerant charging scale to meet the manufacturer's specifications. To determine the refrigerant weight, it is advisable to follow the manufacturer's specifications. Close all valves at manifold gauge and recovery tank. The technician must check for any leaking may occur by using a leak detector. Charging the refrigerant system with correct procedures can ensure a good cooling performance and low energy consumption. This is a good charging practice that every technician encouraged to follow. Checklist 11. Performance test after service procedures. The air conditioner should be switched on and the necessary parameters must be verified for ensuring proper operation. This procedure of performance test should be performed after every service or repair. The tools needed for performance test are Type K thermocouple, 4-way manifold gauge, clamp-on ammeter, and safety valve. In performance test procedures, the technician requires to follow these steps. Switch on the air conditioner and wait for 15 to 30 minutes or refer to manufacturing specifications. Assure that the technician does not block the airflow before measuring the return and supply air temperature. Measure the return air temperature by placing the Type K thermocouple at the return indoor unit. Measure the supply air temperature by placing the Type K thermocouple at the supply indoor unit. The return air temperature and supply air temperature differences must be within 8 to 12 degrees centigrade. If the temperature differences are within 8 to 12 degrees centigrade, the technician can proceed to servicing procedures. However, if the temperature differences is not within 8 to 12 degrees centigrade, the technician needs to inform the owner and suggest further troubleshooting procedures. Low pressure. Securely connect the 4-way manifold gauge to the safety valve and safety valve to the condenser unit in fully closed position. Open the safety valve and record the pressure reading. Make sure the pressure reading achieves manufacturer's specifications. Running ampere. Measure the compressor current by placing the clamp-on ammeter around the live cable at the condenser unit. Refer to manufacturer's specifications for standard current value. The technician requires to fill in servicing sticker after the service procedure is completed. Filling this servicing sticker is one of the good practices for every trained service technician. Checklist 12. Sealing process tube and customer awareness. After completing the charging procedures, the process tube should be sealed. Once the sealing process is done, leak testing should be performed using a spray leak detector or an electronic leak detector before operating the air conditioning system. A well-maintained air conditioning system will ensure optimum performance and contribute to a green environment. The technician requires to help reminding the customer on the next service appointment or maintenance schedule. Before leaving the site, Proper cleaning and housekeeping should be carried out to assure everything in a mannerly order. Department of Environment Malaysia. Alam Sekitar, tanggungjawab bersama.